All right, so guys, we discussed this, discussed this, discussed this, discussed this. I'm going to save this and this for tomorrow. And let's discuss this. I think it'll come in handy right now. Okay, this is called the cubic function. What does it look like? The cubic function looks like this. X to the power 3. And this function is kind of interesting. And if you want to talk about some of the old stuff we did, it's symmetric with regard to the origin, because this leg matches this leg. If you rotate it, this leg matches this leg, symmetric with regard to the origin. It's increasing from the left-hand side. And so it's increasing throughout, really. It's going up. You move from left to right, you're always, y value is always good. So it's an increasing function. What's the domain? What's the range? Well, the domain is going to be negative infinity to positive infinity. And I'm going to show you why. If you move on the curve from left to right, and you think about all the x coordinates, there'll be anything. Sorry. They can be anything. Negative. If you're here, it'll be positive. If you're here, it'll be 0. So it'll be negative infinity to positive infinity. The range, same kind of a deal, guys. The range is going to be negative infinity to positive infinity. And since we're already in the thick of transformations, I can ask you this question. I can ask you this question in English before I graph it. Can somebody tell me what they might expect this to look like? All right, I'm going to put +3. If I do 3, it'll just show up, +3. Okay, it's also green. Let me change the color to something else. I used to know how to change the color, but we'll find out. Well, that's what I'm going to do, guys. I'm going to cheat. Anyway, I don't like that. There was a way to change the color. Okay, Desmos is acting funny, so it's not me. Let's do it here. E of x, yeah, that's much better. I like it red. Equal to x to the power 3 plus 3. Okay, we know, guys, this is a vertical shift. We just discussed it. I'm not surprised that the red curve looks like the green curve pushed up by 3 units. It's a vertical shift. Okay, let's do one more. What do you expect this to be? If I say my g of x this time is the same x cubed, but -3. Well, it should be a vertical shift 3 units down, and that's exactly what it looks like. The blue curve is the original green curve. We're always comparing to our original parent curve. Okay, you can almost ignore it. Okay, ignore the red function. What's the relationship between the green function and the blue function? Well, the blue function is the green function pushed 3 units down. That's what we expect. And if you want to make it move left and right, what would you do? No big deal. You're going to come here. You're going to say instead, and this one you have to do it carefully, guys. Instead of x, you're going to erase x and do x minus 3. And we don't need this 3 anymore. And I'm going to do here, just for consistency, x plus 3. And that's what you would expect. Give me 1 second, okay? So what happened here, guys? Remember, guys, we said if it's -3, it's going to be 3 units to the right. That's exactly what happened. And we said if it's +3, if you replace x with x plus 3, x plus 4, x plus 5, it's going to move this many units to the left. And that's exactly what happened. Okay, so we have discussed horizontal and vertical shifts extensively in the context of 3 or 4 functions. Let's talk about 2 more new things. Okay, this time it will be a reflection with regard to the x-axis and with regard to the y-axis. And I don't think these are that difficult. Let's pause here a little bit, see if people have any questions. Just a little bit. Okay, I did upload problems on MATLAB and try some of the homework problems. I don't know if I'll be able to get to them today. Okay, but try them. You should be able to do many of them, but you should be able to wrap it up tomorrow. And I should be home tomorrow. Okay, so guys, these are our notes, not that you have to know. What happens, guys? It's called reflection with regard to x-axis, okay? I'm gonna bring this guy here. Reflection with regard to x-axis. So the question I'm asking is this. Forget about everything we have done so far. Well, you don't have to forget, but it's a new idea. What happens if I take the f function, f of x is x to the power minus 3, and stick a negative sign right outside? Excuse me. Okay, purple, I like it. Take a look, guys. If I put a negative sign outside, my whole function, my original function was f of x is x cubed. This time, my new function, okay, transformed function, is just a minus sign stuck. That's the only difference, okay? It works with any function, whatever you start with. Okay, you stick a minus sign outside, what happens? It's called a reflection with regard to the y-axis. Well, what's that supposed to mean? Here's your y-axis, okay? This is a reflection of this. This is a reflection of this. So it seems like they put a mirror on the y-axis and the curve is flipped. Some people call it vertical flipped. Some people, but reflection with regard to the y-axis is pretty standard and not only acceptable, it's the term that's more desirable. Don't say flip. So it's basically pretend there's a mirror on the y-axis, not the x-axis. You're gonna, the right-hand side will be like the mirror image of the left-hand side, and so on and so forth. So if you stick a minus sign, it's called reflection with regard to the y-axis. Let's try one more. Let's do the absolute value function. Let's try it here. So if I now take the absolute value function, what happens, guys? This is what it looks like, nothing too surprising. If I put a minus sign, what happens? This one looks like it was reflected with regard to the y-axis. Yeah, x-axis. This part fell here. I'm sorry. This part fell here. The top becomes big. Actually, I have to fix something. I misspoke on the last one. Okay. So this is reflection with regard to the x-axis. The previous example I gave you is not the best one for this because both of the things happen. We'll discuss that later. So if you stick out, so let me start it once again. If you stick a minus sign outside the function, this is going to be reflection. Let's write it down nicely. Reflection with regard to x-axis. Okay, and you want to get that. Okay, now the previous example I gave you with x cube is a little tricky. I'll tell you why it's tricky right now. So that's also, it's actually both. If you take x cubed, but our theory says if you stick a minus sign outside, it should be a reflection with regard to x-axis, and it is. It is. This part is reflected here, and this part is reflected here. Now, y-axis reflection also takes place. That's why this makes it tricky. But again, to summarize, when you take a function and stick a negative sign, it will always be reflection with regard to WRT stands for with regard to the x-axis. So you have to keep that in mind. And that's what this guy is trying to tell us, this little box. When you put a minus f of x, it's reflected about the x-axis. You can almost guess what this is going to be like. This time, let me see how well you can see. If you replace, in the previous example, we stuck a minus sign outside. Now we're sticking it inside. Oh, sticking it inside means what? Means this. Actually, that doesn't bother me if it sits there. So this time, guys, we're going to replace this x with negative x. My original function was f of x. I'm going to make it f of minus x. But what happens this time? You're going to say it'll be y-axis reflection. Okay. And that's a little tricky to see, but unfortunately, we'll have to use this one. We'll have to use this function. So this time, I'm going to I'm not going to put a minus sign outside. I'm going to come in. I'm going to put a negative x inside. Well, our theory says if you replace x with negative x, it will be a reflection with regard to the y-axis, and that's exactly what's going on. That's exactly what's going on. Okay, I'm going to show you a couple of other examples in a second, but I'll pause it a little bit. So let me show you a little tricky one, okay? The tricky one goes as follows. Let's take the absolute value function, okay? The V-shaped function, nothing too fancy, right? What happens, guys, if I take the absolute value function and instead of x, I write negative x. Give me 1 second. It's acting a little funny, but we'll be here. All right. It seems like, guys, hide this function. Let me erase everything. So what's going on, guys? Our theory says if you replace x with negative x, it's a reflection with regard to the y-axis. So this is what we are focusing on. But it seems like nothing has changed. The blue curve completely covers the green curve. The purple curve, you can call it purple. The reason it happens this way, guys, when you do a reflection with regard to the y-axis, and let's write it down here nicely, when you replace x with negative x in any function, it's a reflection with regard to the y-axis. Well, it doesn't show up here because this guy falls on this guy, and this guy falls on this guy, and they seem to kind of cancel out the effect. You can say they're on top of each other. So when I do the purple, make the purple curve active, it is reflecting actually, but you can't see it because the left one completely covers the right one completely covers the red one. Where are we, guys? Anybody wants to tell me how they feel about what we're talking about? Anybody wants to give me a little feedback?
I mean, it doesn't seem that hard.
It is not really that hard. You're right. And the other, go ahead.
It's just a lot of memorizing how like equations go together and then doing the inverse of that.
Exactly. And the good news is it's going to be an open book exam. Make sure you keep your notes handy. So that's the good news. If you were taking the exam face-to-face, yes, you have to remember a lot of things. So let's do a couple of problems. Okay. Again, thank you, Jack, for interacting. Anybody else wants to share? You can always, add. We can listen to multiple people. So anytime you can interrupt me, that's never a problem. So guys, I am going to do a few problems. I don't think we're ready to do all of them. Okay. It's not a real catch, but all these transformations we talked about can happen twice. We can move something. And actually, guys, I don't know if I want to do some of these problems yet today. Let's do something where two things take place at the same time. Well, what's that supposed to mean? Well, x squared. I'm not surprised. This is what it looks like, right? Quadratic function, parabola going through the origin. And then I'm going to do this one. I'm going to replace x. I'm going to replace x with x minus 2. And we know it's going to be a 2-unit shift to the negative is right. And that's exactly what's happening. Okay, the purple one is 2 units to the right. Now I'm going to take the purple one. Okay, I'm going to do another one. It doesn't, h of x is the previous function. And to this function, doesn't matter what function, this g of x is already a transform function. I'm going to add 3. Whenever you add 3 to a function, that transformation, it does what? That transformation moves the purple curve in this case. This is my original curve. What happens here? 2 units to the right, totally agree. Okay, what happens here? 3 units up, totally agree. So I've taken this curve and transformed it really twice. So this curve is going right 2 units, up 3 units. So this should prepare us to do some of the problems from your book, just the first chunk, and I'll be happy with that. So you're going to see 2, 3. I don't think you will see more than 3. You will see at most 3. Let's do a couple of these. Now we are ready. So yeah, okay, another catch. It's not a real catch, guys. Sometime they will give you a curve and I can do the same. You won't be able to graph it. Your Desmos won't let you do it. So you have to genuinely understand what it is that's taking place here. Okay, let's do a couple of them. So they're saying, let's read the text. This is the graph. You don't know, is it x squared? Is it x to the 5? We don't know. I'm going to do a couple. I won't be able to graph it because I don't have a function. But the things we learned will come in handy. We're going to use that language. So again, let me move things around a little bit. Give me 1 second. Okay, guys. All right. I think we're ready. All right. So I'm not going to worry too much about the bottom ones. Actually, we're not even ready. I think we can only handle up to 26. I'll do some of these. Okay. This is my curve. Okay, 17 through 32 refer to this particular curve, and I don't have a way of graphing it. Okay, I have to look at it. Now, we do know when you take a whole function, doesn't matter what it is, if you subtract -1, what will happen? This is going to move the blue curve 1 unit down, and I am supposed to sketch it. And I'm going to try my best. Okay, guys? 1 unit down would look like this. Now you're wondering, how is he going to ask us to do it on the exam? I won't be able to. I will give you, I could be a multiple choice question. I'll give you this picture and give you 4 little pictures. I'm going to say which is the right one. Okay. So you have to know that. So that's number 17. We know whenever you take a function and subtract 1, everything is pushed vertically 1 unit down. We call it vertical shift by 1 unit. And let's do the next one using pink, and then I'm going to eventually erase some of these. 18. According to our theory and exploration, it's going to go up by 1 unit. The blue curve, I'm talking about the blue curve. F of x is blue curve, so it's going to look like this. And it's not going to be perfect. We get it. Do we see, guys, what's going on?
Yes.
Wonderful. So we did 17 and 18, okay? Let's patiently do a few more, okay? So I'm going to, if you don't mind, I'm going to erase all my sketches. All right, so based on our theory, guys, based on our theory, what will this do? -1 means 1 unit to the right not left. Minus is right. And 1 unit to the right, I'm doing it in red, seems like. And it's a little tricky. The blue line, 1 unit to the right, will look like this. Look like this. It's not perfect. Trust me, guys, this is what it's going to look like. Okay, that's how we describe 1 unit to the right. What about +1? Let's use a different color. +1 will be number 20. +1 will be 1 unit to the left. And 1 unit, this blue one, I don't need the red curve anymore. I know I have a couple of black dots from the previous one. I don't think that's that important, but yeah, we got rid of it. So the 1 unit to the left, 1 unit to the left, look, they start here. This one will move 1 unit to the left. This one blue, 1 unit to the left, 1 unit to the left, 1 unit to the left. That's the picture for number 20. I'm going to pause there just a little bit, guys, okay? Again, if I give you this, there will be multiple choice options. All right, so let's try these guys. The next one, at least one. All right, let's try this guy. This guy. We're going to do it in green. Okay, remember here, two things are taking place. You start with princess, -1. That would take the original function f of x and make it go 1 unit to the right. And +2 will be 2 units up. So you're going to take every point, you're going to go 1 unit to the right and then 2 units up. So I'm going to show you this one a little differently. 1 unit to the right, this point, 1 unit to the right, 2 units up will go here. 1 unit to the right, 2 units up will go here. 1 unit to the right will go 2 units up, will go here. And 1 unit to the right will go 2 units up, will go here. Now you have all the important points and make your final move as follows. Not really as bad as sometimes people think. This is how we move 1 unit to the right. -1 means 1 unit to the right. 2 units up means +2. And this one, I won't do it, but I'll just tell you, this is going to be 1 unit to the left and 2 units down. I'm pausing a little bit. I would like to do these two, maybe 1 or 2 here. And we're not ready for anything beyond 27 as of now, but we will be by the end of tomorrow. Okay, guys, let's see. Again, if you have a question, just ask me. If I erase something, I can always redo it. So guys, we discussed today sticking a minus sign outside the function will make the function reflect with regard to the x-axis. Okay, so reflecting with regard to the x-axis, I'm going to highlight the x-axis. That means that's my focus. And reflection is generally very easy. This guy will come here. If something is on the x-axis, it will stay on the x-axis. And this part will go up like so. So this green curve is the reflection of the blue curve with regard to the x-axis. What does that mean? Pretend there's a mirror on the x-axis. The top will be reflected in the bottom half. The bottom half will be reflected in the top half. If anything is on the x-axis, it will stay on the x-axis. Let's try this one. Okay. Let's try the next one. Remember, guys, we said if you replace x inside the function with negative x, it's a reflection with regard to the y-axis. And let's highlight our y-axis. Okay, pretend there's a mirror along the green line. This point will fall here. This point will fall here. This point will fall here. And this point will fall here. Let's use a different color, red. It'll look somewhat, oh, not a good idea. It'll look somewhat like this. And it's not perfect, as you can see, but I can make it a little better. Again, the red curve is reflection of the blue curve with regard to the y-axis. Why y-axis? Because I'm replacing x with negative x inside the function. I'm pausing here a little bit for you guys, okay? All right, guys, let's do this one. Number 25. Let's erase everything I have here. I'm hoping we are recording. Yep. All right, guys. So guys, let's try this. As before, this is a combination of two transformations. So I go with the parentheses first, minus x. What does minus x do? Minus x is this one we just did. So this one is a combination of reflection with regard to the y-axis. I shouldn't have erased it because I need it. Let's do it that way. So the first one, well, this one, I have to first do this one and ignore this for now. All right, guys. So I'm just going to redo it. Seems like my computer didn't save it. So I'm going to redo it. I'm going to ignore the plus one right now. I'll do it in two stages. So the first minus x means I'm going to take the blue curve and reflect it with regard to the y-axis, as we have done 2 seconds ago. Not the perfect picture, but it's not too bad either. Now, adding plus one means I'm going to take my red curve, move it 1 unit up, and I'm going to use my green pen to do that. Moving 1 unit up means all the dots will go 1 unit up. So green answer, green curve is my final answer. Okay, I'm going to pause here a little bit. So really we did up to 26. Okay, we're not going anywhere, but I'll just give you a little recap, but we are almost done really for today. I'll be here, of course, for the last 15 minutes or so, but let me do a little recap about what we did. Okay, so this is our text really. We learned about these functions, graphs, this one, this one, this one, this one, and this one. And we learned about 4 types of transformations. One is, the first one we did is called a vertical shift, goes up and down vertically. Horizontal shifts, they go left and right horizontally. And then we did x-axis reflection and y-axis reflection. And we applied those transformations to these 4 or 5 functions. Tomorrow, we will do this guy and this guy and apply some of the same transformations, and we will learn 2 new transformations. And tomorrow, we should be able to wrap up the section, I believe so. But let's see if you have any questions, guys. Any questions about, ideally about today's lesson, but anything else related to our class? Go ahead, Jack.
No, not really. Everything's
Okay.
pretty simple. So are we all good to go?
Good. So I'm talking to everybody. This will kick me out, and I will be back for another 15 minutes if it kicks me out. But if you want to leave, be my guest. If you want to hang around to answer or ask some questions, totally fine. Okay.
You have a good day, Professor.
You too, Jack, and everyone else. Philip, do you have any questions for me? All right, so I'm going to jump out of this and I'm going to be back. I'm going to hang around here for 15 minutes, guys. Okay. Philip, if you have any questions, come back. Okay.